Hey,
Hi
everyone.
guys, here we are. Me and Mr. Wood just right back at it, picking up right where we left off
Bringing
last
the team
year.
back. Yep, you know it.
Okay, so we're going to go over molecular shapes today. So we've been drawing our Lewis structures. So
Okay.
we have the general 2D, we
Love
got
it.
that down.
Love it. Lines, dots.
Lines, lots
Yeah.
of dots, yeah. So today we're going to look at the 3D structure. Because, of course, we're in 3D. That was supposed to be way cooler than was.
Yeah, because we're,
Okay.
yeah.
Okay,
I
it's been a while.
I liked it. Yeah.
Anyway, well, this is called Vsepr. Okay, so it stands for valence shell electron pair repulsion.
What?
I know. It's a lot. It's a mouthful.
Ridiculous name.
So basically what happens here is because all electrons are negative
Mhm.
and they're like charges, they're
Okay.
going to...
Repel.
See how it says electron, repulsion.
What?
I know,
That's
all
crazy.
ties
That's
in.
awesome.
So what happens is these extra electrons, when they're not being shared, they put a huge, push, if you will, on the shared pairs.
Okay, so pretty much all electrons want to be as far from each other as possible.
Exactly.
Right? Okay.
Kind of like, growing up as a kid. Get away from me, brother.
Totally.
Get away from me, sister. That kind of thing. Okay? So because of that, it gives the molecule a 3D shape.
Nice.
Okay?
Right.
So how do we figure that out? Well, we look first to see the shared pairs,
Okay.
versus the unshared pairs.
So we have to draw our Lewis structure first.
Mm-hmm.
We got to see what's paired, what's not. Okay.
Right. Okay, and when we look at these things, we have to check the central atom. It's only the central atom that matters to determine the shape.
Okay, so only care about the one in the middle. Got it.
Correct, exactly. So a shared pair could be a double bond, a single bond, or triple bond. I'm glad I did those in order.
Yeah. Really made it easy for her. Okay.
Yeah. Single bond, double bond, or triple bond. Okay.
Okay.
And then an unshared pair would be anywhere there's a pair of electrons not being shared.
Okay. So regardless of what kind of bond it is, a bond counts as one,
Yes.
and an unshared pair counts as an unshared pair.
Exactly.
Perfect. Okay.
Okay. So far so good. So if we look right up here at this guy, where my little big hand is at.
Gigantic hand.
Yes.
It's like a Mario hand.
So there's 4 bonding locations. Bonding. How do you want to determine that?
So there's 4 thingies.
4 thingies.
Right,
Yes.
so we got 2 single bonds. That's 2.
2 bonds. Yep.
And then 2 pairs. That's another 2. That's 4.
Right. So 2 unshared.
Electron domains.
Thank you. I could not think of the word.
Got there.
Okay. So we have 2 unshared here and 2 shared pairs.
Okay. Perfect.
Okay. And then this one would be 4 domains, 4 shared.
Gotcha.
Okay.
Nice and
Sorry,
easy.
the
Okay.
D word. Couldn't think of it.
I know.
Man, it's been a while. All right, moving right on. So first, the rules. Okay. We're going to determine the clouds or the domains, if you will.
Okay.
Okay. We're getting there now. So you want to count the shared pairs first. So that's anywhere there's a bond.
Any bond counts as 1.
Correct. So it doesn't matter if it's single bond, a double bond, or triple bond. It only counts as 1 if it's on the same side of the letter, if you will.
Same side of the... Oh, okay.
So if I had C and it had 4 lines on it, doesn't matter if each of those lines, if by that line it was 1 line, 2 line, or 3 lines.
Gotcha. Okay.
Okay.
I see what you do. Yeah.
Yeah, I just want to clear that up a little bit. Sometimes that can be confusing.
No, yeah.
Okay. Then we're gonna count the unshared pairs. So anywhere where there's dots.
Okay, so we're gonna count the number of bonds. Then we're gonna count the number of dots.
Mm-hmm.
Got it.
And that's it. And then we get a chart.
Oh, so we don't even have to really remember anything.
No. So you get this really cool chart.
Wow. That's so cool.
Okay. So it shows you where the domain is. My big hand has gone somewhere. I don't know where it went. Okay. So it shows you the number of bonding domains. So where the bonds are forming.
Okay.
And then non-bonding would be obviously where the unshared pairs would be at.
Okay, so I just count how many bonding there are, how many non-bonding there are, and I look it up, and I get my answer.
Pretty much.
Okay.
Very, very simple.
Nice.
So we're going to kind of start here. Okay? So we have CH4. So we draw our Lewis structure for CH4.
Yep, gotcha.
Okay? We see that there are a total of 4 pairs, right?
Yes.
4 domains.
4 bonds, yes. 4 domains.
So when I go on my chart here, I look and I see, okay, 4 pairs. Where is my big hand?
It's really hard without the little hand. Oh, no.
Oh, no.
Oh, boy.
Oh, no.
Uh-oh. Oh, that didn't
Oh,
help.
my hand is gone.
Oh.
I don't know where my hand went. Okay, so we got 4 bonds. So I'm going to go right where it says bonding domains. 4. I'm pointing and I know you can't see anything.
No, I don't.
Okay, so I look under bonding domains. It's the 3rd column.
Yep.
And I go to 4.
Mhm.
Okay? I have none of them non-bonding. So they're all bonding.
Yep. There's
Okay?
no dots.
No
just
dots
lines.
at all. So I look across. My shape is tetrahedral.
Oh, it's awesome.
Okay? Very simple. So let's try another one.
Whoa!
SO3. I know, I went from really easy to wham.
All right, let me try this one.
Okay.
Okay, so I'm going to count the bonds. I
Mhm.
see that there are 1, 2, 3 bonding domains.
Mm-hmm.
Okay, 3 bonding domains and 1 non-bonded pair of electrons.
Correct. So I'll go in my third column and I'll look down and find a 3. Well, there's 2 options for 3.
Oh, man.
Okay. So the first option you come across, again, I'm pointing. The first option you come across is 3 and 0. Well, that doesn't work for us.
Not the same as 3 and 1.
No, it's not. So then I scroll down and I see that under the tetrahedral for the electron geometry, they have 3 and 1.
That's what we want. 3 bonds, 1 lone pair.
Yep. And we find out that that's called trigonal pyramidal.
Trigonal pyramidal.
Okay.
Isn't that fun?
Did I say it wrong? Trigonal?
Whatever.
Okay, same thing.
It's a triangular pyramid.
Very good. Very good. Okay.
The base is a triangle.
So it's like a little...
Yeah,
gotcha.
Not like the pyramids of Egypt where it's a square pyramid.
No,
mind.
Okay, we're moving on.
Not important.
Okay.
Wow, there's a lot of dots there.
Okay.
Do I have to count all of those dots?
No, because remember, when we're doing this, only have to worry about the central atom.
Oh, okay.
So
we're only looking at N.
Only looking at N.
So much easier now.
Right. So when I look at N, what do you see, Mr. Wood?
Okay, so I see 3 bonds, right? 3 single bonds, so it's 3 bonding domains.
Okay.
1 unshared pair.
Okay.
So it's our good friend, 3 bonding domains, 1 non-bonding domain.
Okay,
3
which
and 1.
was trigonal
Pyramidal.
Man, I keep doing that.
It's okay.
I don't know. Kind of like the off-ball and FUBU thing I did a couple years ago. Okay, moving on. Yeah. SO2. So now we have double bonds. But again, they're only count for 1 domain. Doesn't matter if you have a single, double, or triple in that one spot. It just counts as 1.
I'm just counting that there is a bond there.
Correct, exactly. Okay. So, go ahead.
I've got 2 bonds, right? I've got 2 double bonds, so I've got 2 bonds and 1 non-bonding pair.
Correct.
So 2 and 1.
So then I go and I find 2 and 1, and it happens to be under trigonal pyramidal.
Trigonal planar.
Thank you. And I notice that because of that unshared pair, it says it is bent.
That's fun. It's a bent.
Bent structure, I know. All those other ones sound so fancy, and then you get bent. Okay.
There's seesaw, too.
Oh.
When you get up.
And
when you get up to like 6, yeah.
Yeah, we're not there though. This is just honors, not AP.
I'm just saying it's fun words.
Now,
what? There's no central one.
There is no central one.
What?
I know. These are easy though, because guess what? There's 1 bond, right? And it's a straight line. The only option.
It has to be straight, right? It has
to be a linear.
Because wait, 2 points define a line. 2 atoms are on a line.
So
you can't have 3-dimensional structure.
Exactly. So it's linear.
Crazy.
Okay, so that one's kind of very easy. I know it quite doesn't fit your bonding domains, if you will.
It's like an exception.
It is an exception, but whenever you have just 2, any diatomic really, is just going to be linear.